Hello and welcome to the port of Kiel. We are at the new shore power plant at the Ostseekai to sneak a peek into areas where it usually says no trespassing. During their berthing time in port, the vessels need electrical energy. The shore power supply plant at the Ostseekai enables eco-friendly ship operations with zero emissions in the port of Kiel. With an output of 16 MVA, one of the largest systems in Europe is located here. The concept is really simple, is it? The power comes from the grid of the state capital city of Kiel and is customized to the different requirements of the vessels in the shore power supply plant. The gas-insulated switchgear forms the entrée into the transformer station of the onshore power plant. The 110 kV transformer converts the voltage from 110 kV to 10 kV, which is needed to operate the plant. We continue to the input switchgear. This is where the actual onshore power plant begins. The input transformers feed the converter. Here, the 10 kV input voltage is converted to 2.19 kV voltage, which is required by the frequency converter. The frequency converter is the heart of the system. Only a few ships use the common European grid frequency of 50 Hz on board. Most have an onboard frequency of 60 Hz. This is adjusted by the frequency converter. The output voltage is 10.4 kV. The distribution switchgear distributes the electricity to the Schwedenkai and the Ostseekai. The Schwedenkai has its own output transformer. The output switchgear for the Ostseekai is integrated into the onshore power plant. In both cases, the voltage is now adjusted to 11 or 6.6 kV as required. At the Schwedenkai ferry terminal, the connection to the ship is made via a permanently installed crane arm. At the Ostseekai, the cable vehicle forms a flexible connection between the junction box and the ship. In Kiel, the huge luxury liners at the Ostseekai and the Ropax ferries at the Schwedenkai can thus be supplied with electricity on a daily basis. Another unique feature is the facade of the onshore power plant at the Ostseekai. The LED wall makes a visual statement of the physical processes. The facade of the onshore power plant is so far unique in its kind. During the day, you can well see the outer shell, which has its truly own character with its dynamically structured perforation. In the dark, it transforms into a virtual design level. Once the LEDs hidden in the facade are switched on, there is hardly any limit to diversity and creativity. Just drop by and have a look. Supplying different cruise ships with power requires a flexible cable transfer system at the berth, as the shipside shore power connection points are not all located in the same position. This is why we have installed 3 connection boxes each at every Ostseekai cruise berth. From these connection boxes, a cable truck bridges the remaining distance to the ship. And here it is, the flagship of shore power for cruise vessels, the cable truck. It is steered by remote control to the connection box closest to the ship's connection point and plugged in there. The cable truck can bridge a distance of up to 35 meters. Then it hands over 4 cables and a pilot contact from onshore to onboard. The cables can be managed individually and are taken on board by the ship's crew to be plugged in. Once all the plugs are securely plugged into the ship, it can start to run on shore power and the diesel generators can be switched off. An average cruise ship with the ability to use shore power calling at Kiel thus saves 45 tons of carbon dioxide per call. The Color Line and Stena Line ferries operating daily from Kiel save 2,500 tons of carbon dioxide at the Schwedenkai and 5,061 tons of carbon dioxide at the Schwedenkai every year. Now let's take a closer look at the shore power connection at the Schwedenkai. The cable crane manages the cable transfer to the ship. In contrast to the Ostseekai terminal, we have the sister ships of Stena Line here, whose shore power connection points on board the ships are located almost in the same position. Small variations in the shore power hatch position can be corrected by the swiveling cable crane arm. The crane goes right to the skin of the hull. From here, the plug is lowered to the shore power hatch, where the crew takes it in using a cable hook. The crew moves the crane into its correct position from on board the ship by remote control. Once the cable is plugged in, it is lowered to compensate for possible tidal ranges or any vessel movements. A wind deflector is mounted. The earthing switch is released, and the engineer in the engine room is informed that he can start to switch off the diesel engines.
Our power on board ship. I will connect to the main switchboard. Now it's connecting the breaker between the power supply and shore connection to the ship. And now it's in, and it starts deloading the generators. And there's the last one. So now we are running on shore power.
This is the transformer station at the Schwedenkai. In order to avoid any voltage drop, the transformer and the switchgear are located directly at the berth. The Schwedenkai system communicates permanently with the onshore power supply plant at the Ostseekai that is located around 1.5 kilometers away. Through this remote communication, it gives control commands to the central control system, so no personnel is needed to go to the Ostseekai physically. This brings us much closer to our goal of zero emissions in Kiel's city port.